Hello, Mr. Marconi. My name is Kendra Dorsey, and this is my Milestone 4 summary video. Over the past few weeks, I built a secure proof of concept website using WordPress and GoCMS hosted on Docker containers and reverse proxy handled by Nginx. As you can see below, the command that I ran was 10.10.229.10, and obviously the password is full cell 1 exclamation mark. On my Docker PS, right now I'm connected to my Docker host via SSH, and here you can see the terminal view showing my running containers with a Docker PS command. Initially, I tried deploying the latest version of Ghost with its default setup using SQLite. However, after quite a bit of troubleshooting, I found out, though the Ghost forums and documentation, that recent post versions have dedicated SQLite supported for production environments. That's why I had to make a change. Instead of trying to force it and run SQLite, I created a dedicated MySQL 8 container to the database backend. You can see that container here, Ghost MySQL, running on port 3306. Above that, you can also see the actual Ghost container, which is now successfully connected to MySQL and serving the block content. This two-container approach allowed me to follow best practices by separating concerns. Ghost handles content and fortend, while MySQL handles all the data storage. This is a good example of containerized service architecture using Docker. Down below, here's my Nginx, which is 10.10.229.12. Now I've switched over to my reverse proxy host. I've SSH'd to this machine using secure credentials here. I am checking status Nginx, our web server, and reverse proxy by running the command ps-aux line grep Nginx. You can see the active Nginx processes running here. This confirms that Nginx is up functioning properly on the host. The main job of Nginx is to act as a reverse proxy. That means it listens for incoming web requests on ports 80 and 443 and then forward those requests to the appropriate backend services, in our case, the Ghost container on port 3001 and the WordPress site on a separate port handled on another container. This kind of reverse proxy setup not only simplifies traffic management, but also gives us the opportunity to enforce SSL, add basic security controls, and log external requests, all while keeping the backend containers isolated and protected. Now I will locate you to my network topology diagram. So let's go back. Let's go here. Okay, now let me walk you through the network topology of my project using this diagram. Everything in this setup is hosted within a Promux virtualized environment, which acts as a hypervisor for all my VMs. The IP address range is used here is 10.10.229.24, and the default gateway for all virtual machines is 10.10.229.1. On the left side of the diagram, you'll see that Nginx reverse proxy running on Rocky 8 machine with the IP address of 10.10.229.10. This is the first system to receive incoming traffic from any browser. When a user types in a domain like ghost.example.com, the DNS resolves it to this IP address, and the request is received by Nginx on port 80 or 443. Nginx then uses its configuration rules to determine where to forward the request. If the incoming request is meant for Ghost, it forwards that request to Docker host machine on IP 10.10.229.11, which is also running on Rocky 8. On that machine, a Ghost container is listening internal port 2368 and is mapped to host port 3001. The reverse proxy knows this mapping and directs traffic accordingly. If the request for WordPress instead injects or route the traffic to a different machine, the UM2-base LAMP server on 10.10.229.12, which is running a traditional Apache-MySQL-PHP WordPress stack. This layered setup with a reverse proxy at the edge and services segmented behind it helps isolate services, manage SSL termination in one place, and makes the system easier to scale or secure. Overall, this traffic flow from browser to reverse proxy to Docker container demonstrates how requests are efficiently managed, filtered, and forwarded to their intended destination. Now, I will be taking you to the browser. Let's go to the browser. Okay, now I just opened the browser and typed in 10.10.229.12 -wp admin. And I will be typing in that WP admin. Here we go. All right. Now I just opened the browser and type 10.10.229.12-WP-admin. Go through the plugins and type shield and reinforce separately each time. Now, I'm accessing my WordPress site through the browser at http 10.10.229.12-WP-admin. This confirms that my UM2 base LAMP server is up and running and the WordPress application is fully functional. While setting up security for WordPress, I initially attempted to install popular Layer 7 security plugins like WordFence and Shielded Security. Unfortunately, no matter what I tried, whether searching directly through the admin dashboard or even downloading them externally, I kept running into issues where the plugins couldn't be found or installed. After researching compatibility and plugins, limitations in offline restricted environments, I decided to go with the all-in-one Security A iOS plugin. It's a lightweight, easier to configure, and provides a solid Layer 7 firewall, brute force protection, and login hardening. This plugin allowed me to still implement important security best practices at the application layer, even though the WordFence and Shield weren't working. So in the end, I was able to secure my WordPress site effectively using AIOS. Now, I will be typing in 10.10.229.12, the test post page. Let's go back on this and leave it like that. Oh, sorry about that. Forgot to... Oh, let me retype it in for you. 10.10.229.12. Okay, here we go. Now I'm going to demonstrate that my WordPress site is fully functional by showing you the test post and comment I created earlier. As you can see, I've navigated to the main site view on HTTP, this right here, 10.10.229.12. And here's the best blog post I published that confirms that content management functionally working as accepted. When I click into the post, you can see a sample comment added at the bottom of the page. As you can see right here. Okay. Now, when I click into the post, you can see a simple comment add at the bottom of the page. Just shows that the commenting system is also active and that my WordPress installation is properly communicating with the MySQL database in the backend. This successfully test confirms that not only is the front end rendering correctly, but also the backend services like database and PHP processing are running into issues. To wrap up, I'd like to briefly talk about some key takeaways and how I apply security principles through this project. First, let's talk about defense in depth. This is a layered approach to cybersecurity where multiple levels of defense are implemented to protect systems against potential threats because no single solution is ever foolproof. In my setup, I apply defense in depth by using several layers. At the network level, I use Nginx as a reverse proxy to control incoming traffic and isolate my application container from direct exposure. On the host level, Docker provides isolation between containers, reducing the risk of one service affecting another. At the application level, I harden my WordPress installation and secure file permissions in a Layer 7 firewall using AIOS plugin. Secondly, the process of identifying vulnerabilities, performing configurations, and testing was a major part of this project. I started by reviewing common risk in WordPress deployments, vulnerabilities. I then made key configurations such as moving sensitive files out of the web root, updating all software packages, and limiting plugin use. I followed up by testing my setup through browser-based checks, plugin security scans, initial bad requests to confirm that my reverse proxy and web servers handled them properly. Lastly, this project taught me a lot about WordPress security. I learned that even a simple blog system can also become serious target if not hardened properly. I also realized that not all plugins work in every setup. I had to pivot from WordFence to AIOS due to compatibility issues. But The most important thing I learned is that WordPress is only as secure as environment it's running in. So securing the entire stack from VM to the plugins is essential. So, with that being said, I would want to say thank you, Mr. Marconi, for the opportunity to work on this project. It helped me build real world Linux administration skills, strengthening my understanding of container based deployments, and most importantly, gave me the confidence to deploy and secure web infrastructure from scratch. Thank you. My name is Keandria Dorsey, and I hope you enjoyed my presentation.